Hello, everyone. Thank you for joining us today. This is the 451 Research and MemSQL Webcast, our in-memory computing and market predictions for 2017. Today we have Jason Stamper, an analyst from 451 Research, and Gary Orenstein, Chief Marketing Officer at MemSQL, to talk to you about what they're seeing in memory today and in the future. If you have questions, feel free to submit those through the question box on the GoToWebinar app, and we will be taking questions at the very end of the presentation. So for now, I'd like to hand it over to Jason Stamper to start off the presentation.
Great. Well, thanks very much, Emily, for that introduction. So, yes, my name's Jason Stamper. I am the analyst in 451 Data Platforms and Analytics. And I cover operational databases, data grids, and data fabrics. I also cover some of the NoSQL and Hadoop space, along with colleagues here at 451 Research. A bit about our company then. 451 Research is the fourth largest analyst firm, and after a number of acquisitions and being founded in 2000, we actually go right from the data center to the edge of analytics in terms of understanding cloud data, databases. We bought a company called Uptime Institute, which helps us to understand and certifies data centers themselves. We bought Yankee Group, so we understand mobile technology, and so on. Like I said, we're the fourth largest, over 200 staff altogether, well over 100 analysts now since this slide was produced. And we also have something called Voice of the Enterprise, or VOTE, which I'll be talking a bit about some of their data, which we use to survey regularly end users of technology, so that rather than just espousing our own opinions and listening to the latest trends in the industry, we're also able to have some hard and fast quantitative data to understand what organizations are really doing. So I'm based in the UK, but we also have offices in New York, San Francisco, a few small offices around Asia, the Philippines, and Australia as well. You know, 451 Research, I'm in the data platforms and analytics team here. There's 5 of us, and you know, so we have to look at all of these different technologies that organizations use for data platforms and analytics, and of course there are quite a few. And being analysts, we try and understand, put them in various categories and buckets and so on, and try and understand where they play a role, how in some cases they overlap, and of course, you know, where some of them compete with one another, and how indeed organizations are using them. But as I say, we try to take quite a pragmatic approach to data platforms and analytics. So as you'll see in the very outside band, the light grey color, we circle everything with business case and domain knowledge on the basis that it's very, very difficult to make the case for any technologies without a strong and reliable business case that has been proven and tested. And indeed one that's delivered with domain knowledge either from in-house experts or external help. So we think that's very key. And then if you look at the bullseye of this graph around the 3 V's that's been described for the changing nature of data in an organization around variety, velocity, and volume, we also put economics at the center of that, in that it's not just the speed of data, the speed with which organizations want to analyze it that has changed. It's also the pace at which business users and analysts need that data in a digestible format that enables them to make some sensible changes to their business models and new approaches and new marketing strategies, and so on. And also not just in terms of how quickly you're able to ingest data into a data platform and subsequently analyze it, but also we think is important is how quickly you're able to start with a new project around a data platform or a particular business need and get to the stage where you are able to actually analyze that data. In other words, what is the kind of development life cycle that you are looking at when it comes to, you know, starting off a particular data initiative and getting to the stage where you're able to deliver some kind of value from that data. So that's another important point in terms of You know, the latencies that we talk about, we've heard of real-time and close to real-time, machine real-time and human real-time are two of the ones that we've heard about, but also that ability for the data lifecycle itself to be collapsed and contracted to some extent as much as is possible. You know, it comes as no surprise to anybody that we're seeing considerable growth in the data platforms and analytics space. Most of you will have heard statistics around data volume growth. I don't need to go through those, that, you know, data volumes are you know, doubling every 18 months, every 12 months, every 6 months, depending on your particular company and which industry you're in. But suffice to say, our forecast for total data platforms and analytics is showing very healthy growth through 2015 to 2020 on a compound aggregate growth basis. And I don't think that's very surprising. What's notable is that there's around 284 vendors that we include. We add a few to these each quarter, and a couple obviously disappear that haven't made it for one reason or another, or been bought and subsumed into another vendor. And there are 9 markets in total that we analyze. So Emily, if we can move on to the next slide. So that's part of how we segment the industry and start to look at the different vendors that we cover in the space. So let's talk about the main topic of today's discussion then, in-memory databases. Well, Wikipedia, as usual, has done quite a good job of you know, defining what an in-memory database is. I'm sure most of you on the call will be fairly familiar, so I won't go into too much detail. This is for those that aren't as up to speed on this technology. It's a simple primer kind of thing. But basically, there's a number of options to in-memory databases, but the key thing is, of course, the ability to use memory, which is an order of magnitude, usually 10 to 50 times faster than disk for read and write access, to speed up applications both for transactions and analytics. But the in-memory database space has also benefited massively from the fact that that massive speed increase also enables them to handle not just transactional workloads, but also potentially at the same time handle analytic workloads. And this is what 451 terms multimodal databases, 2 different modes where you're able to do analytics and transactions at the time. And Emily, if we move to the next slide, you'll also see that as organizations have moved towards this kind of technology, they've found that there are a number of different offerings available to them from the vendors of this technology. So let's talk about a few of those options. Well, we're here, of course, in part with not just 451 Research, but MemSQL, who will talk to you, I'm sure, about pure in-memory databases. But there's also disk-based and persistent databases, which is where some of the larger, let's say, incumbent database vendors, we know who those are, have seen the increasing need amongst organizations to do analytics as well as transactions on large data sets, and have seen at the same time a need for improved performance and speed in terms of decision making, being able to get real, you know, solid answers from some of that data. So some of those companies have added what they have called in-memory options, or they've just added the ability to do an in-memory column store alongside their transactional data. So they've gone from a very straightforward, well, I say straightforward, obviously these things have been in development since the late 60s, but they've gone from a row and column based relational database to something that starts to also pull out indexes or aggregates of data into a column store, which is better for the likes of analytics, because it tends to pull out things like summary data and so on, which means that instead of a particular query having to trawl rows and columns, which is obviously quite time consuming, if you can imagine trying to cross a road that had you know, squares all across it and cover every single square, it takes a much longer time than if you have a straightforward zebra crossing across it, in which all of the key data that you happen to need is in that particular column. There are pros and cons about that approach, which I'm going to come on to talk to in a moment. But Emily, if we move on to the next slide, I'll just finish by saying that there's also the in-memory data grid or fabric opportunity, which requires putting or sliding, if you like, an in-memory cache or fabric between applications and the database itself. Again, I'm going to talk about some of the pros and cons of that approach. It's slightly different to a database in the sense that they still tend to persist data to disk, although some vendors are even changing what they do there so that they can store data in the in-memory fabric to some extent, or at least some of a subset of that data. So slightly different to a pure in-memory database and an in-memory database option, as we call them, but nevertheless an interesting option. The data grids and fabrics, an interesting proposition for companies that don't want to make many changes to their back-end database infrastructure. So I've talked about 3 of those different types of in-memory data platforms, but let's briefly pause and ask what is driving this move to in-memory adoption in the first place. So many of you will see this in your organization, and I'm sure that's partly one of the reasons some of you are on the webinar in the first place. But of course, if you look at it, if you step back and look at it, it's not just the number of users and transactions that are increasing. We've heard of websites, starting up in China that have ended up with 16 million users within several weeks that compete with Facebook and the like. Of course, if you look back a few years, 16 million users in a few weeks was unheard of. That increasingly is not that an uncommon business model where things can very quickly become quite viral. And in areas such as online gaming, e-commerce and the like, there's huge pressure on organizations to be able to grow very, very fast, even before a huge amount of revenue is coming off these things. So to some extent, that pressure to grow very rapidly has equally put pressure on some of the older relational databases approaches, which, depending on what you were trying to do and what you really need from that data platform, can end up quite expensive for all but the most ACID compliant types of transactions. Of course, more users and transactions means more data, and of course in the era of the Internet of Things, that's only going to grow exponentially. More data means reading that data more often, and of course writing it back to the database as well. And many of those older traditional systems are running out of capacity. It's nearly always possible to scale them up in some way, but there's also always a cost involved, which sometimes can be prohibitive, depending on the business model and where the value is really coming from, whether or not some of these users are actually paying for the service just yet. And all of those pressures have meant that some of the more traditional data platforms have struggled with declining throughput or inconsistent performance or failing or going down too often, or indeed having too large a backup window, not being able to do incremental and flexible backups and the like. And then the other big problem, I talked about multimodal, which is our view of being able to do transactions as well as analytics. And as Emily moves to the next slide, I'll just finish this one by saying that the cost of ETL processes is in our estimation, around 80% of most business intelligence projects. And for that reason, more and more organizations are interested to see whether they can avoid that step altogether, the extract, transform, and load process, which is used to take data from transactional databases into some form of analytical database or data warehouse and do some processing on the way. It's not to say ETL is going away overnight. There's still many good reasons and many cases where it's the best way of doing various types of data transformation and integration. But nevertheless, for more and more companies, they're looking at ways that they can avoid that ETL process, reduce the cost of it by looking at multimodal opportunities such as MemSQL and their ilk that are able to do both transactions and analytics on one data platform for a vast number of use cases. So being an analyst company, we like to draw pretty pictures, of course. And this is one, we're going to send you a copy of the slides. I know some of the colors are a little bit similar to other colors. This can be improved. But this gives you some idea of what's happening in the different categories that we track. As I mentioned, there are 9 different categories of data platforms and analytics in particular that we think are most worthy of tracking. There are some other very few minor ones that we also look at, but these are the biggest. And so let's start at the bottom, actually, which is the darkest blue, and they're operational databases. And as discussed, in some cases, those incumbent vendors have struggled to keep up with the latest requirements in that space. Nevertheless, it's by far the biggest chunk. It's by far worth the most money to those vendors and anyone else playing in this space. And despite the fact it's not growing as fast as some other sectors because it's relatively mature, it is still growing. So certainly not to be written off at all, and certainly isn't dying off or going away anytime soon, in our opinion. The next segment up is the analytic databases and data warehousing. We think that sector is growing at a relatively slow pace, but again, isn't dying off anytime soon, and so many organizations already have huge investment in data warehousing and analytics and still want to continue that. Reporting analytics really isn't the subject of this particular call because that's kind of the front-end visualization, that's the green chunk. And then, as you'll see, there are smaller sectors up at the top of these bars which are around distributed data grids and caches, which we think are going to grow quite strongly. Data management and integration, which is the orange chunk, and search, which is the thin grey layer, which, as you can see, although it's very small, grows quite fast as we've seen organizations move towards search-based technologies that can also search over things like relational technology. So that's one way to look at it, Emily, if we can move forward to the next slide. And just as we do that, it's also worth just reminding everybody that you know, the slices of each of those chunks are also growing strongly as a group. As I said, 14% CAGR from 2015 to 2020 in our forecasts. So let's ask, you know, which questions, or what are some of the good questions to ask if you are considering an in-memory database of one shape or form or another, or an in-memory data platform, shall we say, because you could, of course, also look at in-memory data grids and fabrics and in-memory options. Well, I think one of the obvious ones that we hear from clients that we engage with and when we do consulting projects and so on is, does moving to in-memory require making my data set smaller? Will my total database fit in an in-memory database or not? And the answer is, it's a good question to ask. There isn't a right or wrong here. In most cases, the in-memory database companies these days can scale to many, many terabytes, and it shouldn't ever come up as a problem. And if it does, the next question to ask is, if it doesn't fit all in pure in-memory database, what are my options for persisting some of that data either to disk or something like Hadoop or perhaps SSD or some other form of data storage, you know, if the in-memory size gets a little bit difficult to manage. So it's certainly a question worth asking, but I think in more and more cases, many of the vendors in this space will be able to answer it satisfactorily. Is the platform optimized for analytics, transactions, or both? Again, it's worth asking. One of the advantages, as I've mentioned, of in-memory is that it is often able to handle both. But sometimes the vendor will be very honest with you and say, you know what, we can do both if you really want to, but really our focus is on operational use cases or on analytic use cases, and this is why we think we're particularly suited to those, and often partner with a different ecosystem for different pieces of your requirements. Does it have ACID compliance? It's related to that transactional question, but not all transactions require ACID compliance. ACID is the phrase that's used to describe the most reliable kind of transactions that you can have on a data platform, that they remain durable regardless of what happens, and transactions aren't lost and so on. But there's different ways of handling it, and there are some compromises that can be made depending on your use case. You might be able to run transactions without ACID compliance, so it kind of depends. Again, if many of your users need to write their queries in SQL, you might want to ask about SQL support. Are you particular fans of open source or community editions? Would you like to start for free and test out some data before you, you know, get further into proof of concepts? Remember that open source doesn't necessarily remain free forever. The phrase that's often used is open source is free like a puppy. You know, it starts off almost free at point of sale, but it costs a lot of money over its lifetime. So it can be free in terms of startup costs, but not necessarily free longer term, or even inexpensive longer term if you're having to do lots of things yourself manually. And then as Emily hopefully moves us on to the next slide, Of course, there are enterprise requirements among such things, such as cross-center data center replication, clustering, some of the security protocols that are required, SSL, and more. And in most cases, or in many cases, depending on if you're looking at some of the open source options, for example, those won't be included as open source. You may be able to get them from the commercial vendor supporting the open source project. And likewise, in more and more cases, if you go straight to a commercial proprietary technology, those sorts of things are considered part and parcel of an essential production, deployment-ready, enterprise-ready, carrier-grade technology. So important to have. Now, I've mentioned a few of these. Getting towards the last minute or two of my talk. Some of the pros and cons of these different options then. Well, in-memory options added to existing relational databases have the advantage of not having to rewrite any applications. The drawback is that in many cases, from what we've heard from clients, is that they can still be a relatively expensive option to add to what was already a not inexpensive data platform to start with. Of course, part of what you're paying for there is investment since, as I say, the late 60s, early 70s, right through today in making these technologies as robust and reliable as they possibly can have done. But that doesn't necessarily suit every business requirement, and not every application needs to be as reliable and robust as others. And some are more kind of in terms of visualizing data rather than heavily transactional. They might be offloading certain workloads from the transactional databases and doing other bits and pieces. So different pros and cons there. The pure in-memory databases have the advantage in some cases of being able to, as I say, be multimodal and handle analytics and transactions, which can potentially save you a lot of money in terms of your ETL process and your data warehousing. And they also have that huge advantage in terms of low latency, performance, and speed, which more and more organizations are looking for as they want to make decisions based on data in real time, or at least human real time, which is anywhere between a few seconds and 10 seconds, which is the time it takes a human to see something and act on it. There's data streaming offerings too. Won't spend too long on that here because I think it's a slightly different discussion, but they are able to ingest and filter and process data. These have evolved out of complex event processing engines to some extent, but in most cases they aren't a data storage engine either, so it does require adding some level of complexity to your architecture. If you're adding those, you still need to think about what you're doing for the actual data storage and analytics. And then obviously there's a decision between cloud, hybrid, and on-premises. In many cases, in our experience, that comes down to companies' personal preference and things like what the security officers, auditors, and the board think about putting data in the cloud. But there are options for these in all of the above spaces, in memory, streaming, and adding optional columnar stores to relational databases. You can do all of those with different vendors in the cloud or on premises, depending who you talk to. And then finally, I've talked about in-memory data grids and caches to some extent. As Emily, I think we moved through my last slide or two. And in that space, the big advantage is the ability to not have to rewrite applications because it slides between the application and the database layer. The big disadvantage is you still have the same database issue at the back end if that's an issue around cost and scale and so on. You increase performance, but at the same time add another layer of complexity. You might need new skills as well. So some disadvantages, but also clearly some strong advantages, and we see that sector growing quite well too. So my last but one slide then is a few predictions as we go forward, is that we think multimodal databases are becoming table stakes. We think that in-memory databases will grow very strongly, both those that are pure, but we also expect the incumbents to start to add more customers around that space as their requirements grow and they choose to stay with the vendor they happen to be with. And we think the particular areas that these in-memory technologies will grow fastest are those listed here around the likes of e-commerce and financial services. But we think that all businesses are waking up to the idea of latency sensitivity and the importance of fast data. We also think, which is a whole other topic that I haven't got time to go into much depth on here, is around the Internet of Things, which I've done quite a bit of work around in terms of its impact on data platforms and analytics. And we think that it's certainly a real thing, if you like, to repeat the phrase, and it's going to grow very fast. And it will also put additional pressure on more traditional data architectures that aren't suitable for the vast number of packets of data that will be coming into the data center, not every few seconds, but in microseconds and milliseconds. And finally, just to add one note of humor, of course, I produced this slide deck late last week, but I was completely right. As it happens, there is a new president of the United States, and Andy Murray did indeed go on to become the number one world tennis champion. So, Emily, on my very last slide, I think there's just a sign out to say thank you, everybody, for listening. And now it's with great pleasure, Emily, that I can hand over to Gary Orenstein from MemSQL. Thank you.
Well, thanks very much, Jason, and great to get that background. I wanted to shift a little bit and talk about architecting solutions within memory. And key to that is that the nature of transactions has changed dramatically over the years. So we're going from a world of traditional transactions that were largely batch-oriented and had a set of characteristics that matched those kind of batch processes and traditional enterprise needs. But we also have a new set of modern transactions, much more focused on a real-time world. Both of these types of transactions merit a certain level of requirements, but at the same time, we also see them converging and defining this new single set of requirements. So specifically, of course, real-time is what the business world expects today. The idea of exactly once is that of pushing messages through a workflow where they're delivered once and counted once and don't get repeated. And this is, of course, critical for enterprise workloads with things like customer orders or service tickets, a little bit different than some of the transaction activity in the IoT world, which is sensor and events driven, where if you miss one or if you have duplicates, it's not as big a deal. Of course, we have to have workloads that are governed. We need different types of structure and the ability to handle different types of structure, and this is what Jason referred to as the multi-model approach. And we need to be able to collect data from all types of sources, both traditional enterprise application sources, but new sources such as real-time streams that come through message queues, again, driven by machine data or sensor data or the plethora of data that we have from web and mobile application activity. All of this means that we're heading to this need for a real-time data platform, which includes the ability to process both real-time and batch data, and the ability to handle both the traditional transactions as well as the modern transactions. Now, from a MemSQL perspective, we consider that need as a whole system. And MemSQL is a real-time database platform for handling both transactions and analytics. This merge of these workloads represents, in many cases, the elimination of the ETL process or the reduction to where it's happening in real time. Also, integrating the streaming capability into that platform allows native ingest from popular real-time tools such as Kafka or Spark. Having those things together allows for a very consolidated, high-performance, easy-to-manage solution where the focal point can be delivering real-time analytics as opposed to having to stitch too many disparate pieces together. But it's also important that we carry that forward to fit into a much larger ecosystem. And in this diagram, you can see the range of integrations that are available with a platform like MemSQL, including things on the left-hand side representing inputs, including things on the right-hand side representing our ultimate goal, which is to deliver real-time applications and real-time business intelligence dashboards, and to do so on a foundation of choice where customers can choose either the cloud of their choice or the data center of their choice, including their own, and different orchestration frameworks, including modern approaches with containers. This really is the entirety of the ecosystem in which companies are building real-time solutions based on in-memory technologies. And now I wanted to jump into two specific industry examples which we see on the front lines driving a tremendous amount of adoption of these type of products and implementations. These are, of course, not the only industry sectors that are experiencing the growth in real-time analytics and real-time workflows, but two great examples for us to dive a little bit deeper into. But first, I wanted to begin with this idea of the customer 360 and the data-driven experiences that we see. This is a chart from our friends at 451 Research and shows, from the eye of a customer, just how many bits and pieces there are in their universe as they engage with the company. Of course, there's a huge effort in the business-to-consumer world about customer 360 activities. There's an equally strong effort in the business-to-business world about identifying these customer 360-centric opportunities. And we have one great example of MemSQL and Dell working together, where Dell EMC adopted MemSQL to help with a customer 360 application. We were very fortunate just a couple of months ago at the Strata and Hadoop world that Daryl Smith, the chief data platform architect at EMC, was able to share a lot of this detail with the Strata audience. So EMC specifically wanted to develop this application. They call it CALM, Customer Asset Lifecycle Management, for enterprise sales professionals who need accurate and timely customer information to provide these up-to-the-minute dashboards. And you can imagine, for a person who's working with premium B2B IT technology, that when they go visit a particular customer, they really want to have a good handle of what's going on at that customer at that moment, including anything that may have happened the day before or the night before. That they want that engagement to be as deep as possible. So EMC looked at their data lake architecture and all of the tools that they had available to them, and decided that in order to achieve, in particular, aggregations and joins across lots of disparate data sets, they needed an in-memory database so that they could deliver fast and responsive queries to the account team in the field as they were going out. So, specifically what folks were looking at is how do we deliver real-time updates to customers in the sales team? And how do we make sure that they're seeing things at the same time as the customer? So this ability to personalize and really improve operational efficiency was critical to them. From a technical perspective, they were able to enable joins across multiple distributed data sets. This allowed, for example, the aggregation of information between customer database and the service ticket database and the monitoring that they had on the customer's products. So all of that came together in a great way to help Dell deliver these real-time customer 360 views for their team engaging with Dell EMC customers. Another area that's experiencing tremendous growth is that of supply chain and supply chain logistics. Every day we see stories about Amazon and their soon-to-be drone deliveries. FedEx continues to set the pace along with UPS about delivering more and more packages with real-time tracking. And recently, Uber has announced, their efforts through the acquisition of Auto to go into the trucking industry and to be able to match shippers and trucks in real time. So across the board, this idea of the supply chain and the logistics and managing this in real time has become critical. We have a chance to look at some work from 451 again to see the evolution and the adoption of machine learning in these areas. And you can imagine that with the patterns of transportation and logistics and the supply chain and the ability to track that data, there are some rich opportunities to apply machine learning and predictive analytics to the equation. I wanted to dive in more specifically with a showcase application that MemSQL put together called MEMX, which is providing real-time analytics on a global supply chain to understand where things can be optimized, and using predictive analytics to understand where the pressure points may be in the supply chain so they can be alleviated. From a technical benefits perspective, a solution like MEMX is processing 2 million data points per second based on thousands of sensors across thousands of warehouses. And what's critical about this configuration is the ability to ingest data in real time, but to query it in real time as well. The configuration combines MemSQL as an in-memory database, Apache Kafka as a memory-centric message queue, Streamliner, which is an integrated version of Apache Spark used with MemSQL, and bringing machine learning into the process and predictive analytics to understand, again, the pressure points of these data warehouses, these shipping warehouses. But they have a lot of data too. So this is an example of the screenshot. In motion, what ends up happening is tracking the throughput of the individual warehouses to understand what's functioning well, where there may be gaps, and using pattern recognition of the data through machine learning to develop predictive insight into how these warehouses will perform in the future. So let's dive in specifically to the configuration. What you can see here is we've got sensor information coming in through Kafka, real-time message queue. And then what happens is once we're in the database, we're able to execute machine learning through real-time scoring. So by looking at the activity and the throughput of these individual warehouses, and based on historical trends of when a particular warehouse might reach a break point or a bottleneck, using these scoring models as data is coming in, that data can be scored in real time to predict the likelihood of a slowdown or a bottleneck or an interruption in a particular logistical warehouse. And what happens with that real-time score is the raw sensor data of throughput going through is co-located in the same table and in the same row as the score, the predictive score on that data. This means that analysts get a very concise and consolidated view of everything they need to execute simple queries to determine sophisticated predictive analytics in terms of the result. And so that all happens within the construct of using MemSQL for real-time ingest, real-time scoring, real-time database, and building a sophisticated user interface on top to showcase what's happening visually. So that's an example of a couple of industry sectors that we just wanted to touch on to provide some context for this whole in-memory wave. We're going to take a look at some of the questions and maybe shoot one or two to Jason and myself as we're wrapped up with the primary content. So Emily, did we have any questions that came on and you want to send one to Jason perhaps to get started?
Yeah, I've seen a couple that have come in so far. So Jason, why don't I share the first one with you? It's how can I ensure that my data is safe when everything is stored in memory?
Um, it's a good question, and it's one that companies absolutely should be asking and making sure that is answered. Because of course, especially if it's being used for transactional systems, you can't afford to lose any data, and you can't afford transactions to come back incorrect. Now, I'll let Gary come in on this in a moment, but the in-memory database technology players in different ways have ensured that because memory is inherently volatile, there are still ways of recovering from any kind of outage, whether that's some kind of power cut, a problem in a particular node within a cluster or a cluster itself. And increasingly, as I mentioned on one of my slides, ensure that you're able to do things like cross data center replication, backups to disk, so that if something goes wrong, you can recover from there and ensure eventual consistency. And indeed, they do offer ACID compliance, which, as I mentioned, was the most important requirement for some companies in terms of their ultimate, transactions that they can't afford to lose at any cost, and they need to not pause applications while things are checked against different platforms. So I'll let Gary come in on there, because I'm sure on a technical basis he's got more to add.
Thanks very much, Jason. Yeah, we frequently get this as a common question: how does my data persist when you talk about an in-memory database? Just to give you some specific product architectural examples with MemSQL, MemSQL actually stores data in memory, but also on disk. And that depends on the table that you're working with. So you might choose to have all the data in memory, and then behind the scenes there's a transaction log that goes to disk, snapshots that go to disk, backups that go to disk. You might also choose to have a table type that stores data on disk, so you can have a larger capacity for storing data and permanently, and then using memory for acceleration. So of course, in building mission-critical databases, data durability and persistence is critical, and there are a number of mechanisms that are in place with systems like MemSQL and others to ensure that this happens. I think we'll take one more question that we've got from the line there, Emily. What have we?
Great. Here's another one. How can I incorporate an in-memory solution into my existing stack?
So there are a couple of ways that you can include in-memory solutions without sort of disrupting the existing environment, and I'll detail three, and then see if Jason wants to add anything from his perspective. But one is to complement and do real-time analytics next to your existing database. So you might have a database that's working well, handling your transaction load, but because of performance or scalability reasons, you're not able to give a large team of analysts direct access to the database for analytics. So you might move that data over to a system like MemSQL using industry standard connectors like ODBC or JDBC to move the data over and then build a rich analytics platform. That's one scenario. Another scenario might be ingesting data quickly. This is an area where MemSQL excels in rapidly collecting all kinds of data, and then you could stage that into your traditional system over time. And a third area is working with modern technologies like Apache Kafka and Apache Spark. MemSQL supports native connectivity to those software solutions, and sometimes that can be an important part of building a new real-time data pipeline, again, to complement or enhance some of your existing areas. So those are a few ideas about using at least MemSQL to complement. Jason, did you have any thoughts to share on complementing with existing solutions, bringing in-memory into the picture?
I would say only that, another way to look at it, you talked about some of the architectures, which I absolutely agree with. The other way to look at it is about, starting off with some baby steps and growing from there, and thinking about introducing an in-memory offering in, for example, a new application that you think needs particular pace and performance, or that you want to, kick the tires of an in-memory database, such as MemSQL, for example. and work out what works and what works less well for you and your team, and the kind of transactions or analytics you're trying to do, and grow it from there. So again, Gary's absolutely right about the architectural decisions, but you can also, of course, not necessarily boil the ocean straight away, and very few companies would be able to, without potentially not just millions but $1 billion investment, replace their entire incumbent legacy transactional relational database with something overnight. So I suppose some forward planning and look at where does it not work. First of all, start with some smaller projects perhaps. I'm not saying ones that aren't mission critical, but start with some smaller new projects and see how it can grow from there. Once you start to, your team start to build up their own skills and learn skills from organizations like MemSQL as they come in to help with those projects.
Great. Well, I'd like to thank everyone for their participation today, and for those who shared questions, thank you. You'll see the Twitter handles for both of our speakers listed. The presentation from today's webcast is available at slideshare.net/memsql, and we look forward to your participation on our next webcast. Have a great day, everyone.
Thanks, everyone.